at these next few problems. They want us to not determine the value of all 6 trigonometric functions, so be careful, just the signs of the trig functions. When they're asking for the signs, they're asking, are we going to end up with positives or negatives? That's all they're asking. So the best thing to do is to first figure out where you're going to land if you have this angle. Well, 84 degrees, it's positive, means you're going to go counterclockwise and be just shy of 90. Means you'll be landing in quadrant 1 here. That's going to be our 84 degrees. So what do we know about points in this quadrant, x's and y's? Is that both x's and y's will be positive. So let's kind of list these out. We've got to worry about x, y, and r for our trig functions. Well, if you're in the first quadrant, let's see, x's are positive. We also know that y's are positive, and we also know that r is no matter what going to be positive, because it's got squareds and then we're adding 2 squareds, so you have to have a positive always with r. So what does that mean about all 6 of my trig functions? It means no matter what, if we are dividing any pair of numbers and they're all positive, which they all are, we'll still end up with a positive. So it means that all 6 trig functions are going to have to be positive because all we have are positive numbers. So that one was pretty nice and straightforward. Okay, let's take a look at another one like in problem B. B won't be as straightforward because we're in a different quadrant. We're not dealing with all positives. So let's see where 195 lands us. So drawing our angle, you start with the x-axis and work your way around. So if we stop here, it's 180. We want to go a little bit. So if we go just the other side of this, we'll go to 180. So we don't want to stop there. We're going to keep going. A little bit past that, so we end up over here and in quadrant number 3. That's about our 195 degrees. It gives you a good idea of where we're landing. What do we know about points here in quadrant 3, x's and y's? Well, let's talk about our x, y's, and r's. Well, we do know that x's are negative in quadrant 3. We also know that y's are negative in quadrant 3. And we know that no matter what, r's are always positive because they come from the Pythagorean theorem and squaring things. So the first thing that we want to do is talk about sine. Remember that sine of whatever our angle is going to be, and I'm just going to leave it as theta, as whatever our angle is going to be opposite over hypotenuse, which means y over r. Well, y is negative, r is positive. Well, a negative divided by a positive does get you a negative. So we get a negative for sine. Let's take a look at cosecant. Cosecant is going to be the reciprocal of sine, so it'll be r over y. So it means you'll have the same numbers, just flipped upside down. Well, what happens when you take a negative number and you flip it upside down? It will still stay negative. It's just the actual number will be upside down. Okay, let's talk about the next couple. Cosine. Well, remember, cosine is adjacent over hypotenuse. Well, adjacent is the x and hypotenuse is your r. Well, x's will be negative, and r's will be positive. So a negative divided by a positive will get you a negative. So now we can talk about secant, which is its reciprocal, and we just said that it would mean that you're going to flip it upside down, which would be an r over an x then. You'd still have a positive divided by a negative, which means you're still going to have a negative value. It makes sense. If you flip a negative number upside down, it's still negative. Last one, tangent. Tangent is TOA, which is going to be opposite over adjacent. Well, opposite was the y, over adjacent is your x. So what do we know about this? That will be a negative for your y value on top and a negative for your x value on the bottom. Well, a negative divided by a negative will give you a positive value for your tangent. And then your cotangent will be the same thing, just flipped upside down. So it would be x over y. So you'd still end up with a negative divided by a negative, which would still give you a positive. And what you notice is your two pairs that match up, that are reciprocals, always have to have the exact same sign. Let's take a look at a couple more examples. These next few examples want us to identify the quadrant or quadrants of an angle that satisfy the given conditions. Well, the first condition we want to satisfy, according to this one, is that cosine needs to be greater than 0. That's our first condition. Cosine needs to be greater than 0. The question is, what does that mean? So cosine theta needs to be greater than 0. Well, remember that greater than 0 means that we want a positive value. Okay, well then we need to start talking about what is cosine. Well, cosine is the adjacent over hypotenuse, which is, remember, an x over the hypotenuse r. Well, we already know that r is always positive because it comes from the Pythagorean theorem. So the only way for us to get a positive value, something greater than 0, for our cosine is if the top is also positive then. Because we'll have a positive divided by a positive, which is a positive. So, what quadrants give us a positive x value? Well, there's two quadrants that give us a positive x value. That's everything to the right over here, which would be quadrants 1 and quadrant 4. So far we have limited ourselves down from the 4 quadrants to only 2. Quadrants 1 and quadrants 4. Those are the two values that give you positive x values in those two quadrants. However, let's see, they did give us one more piece of information, so let's kind of dissect that. They also told us that they want secant to be positive. So they said secant theta also needs to be greater than 0, which also means that they want secant to be positive. Well, what is secant? Secant is just the reciprocal of cosine. So remember, we already said we wanted cosine to be positive. Well, cosine is going to be positive in the first and the fourth. When is secant positive? Secant's positive whenever cosine's positive. So secant is positive whenever cosine is positive, which happens in quadrants 1 and quadrants 4. So the overlap is, when are both cosine and secant both positive? Well, they both are positive in quadrants 1 and 4. And that's it. Let's take a look at another one. Let's take a look at B. In B, they want us to look at cosine of theta being less than 0 is our first kind of point of interest. So we've got cosine of theta, and we want it to be less than 0. Well, remember that less than 0 means now we want it to be, instead of positive, we want it to be negative. Well, remember, again, that cosine of an angle is adjacent over hypotenuse, which means x over r. We already know that r is always positive. So if we want a negative, as they're suggesting here for a cosine, the only way to get a negative when the bottom's already positive, then the top has to be negative. It means our x values need to be negative. Well, when are x values negative? X values are negative on the left side of the graphs over here in quadrants 2 and quadrants 3. So that is when cosine is negative. Okay. One more thing they want to make sure. They also want to make sure that sine is less than 0. So let's work on that one now. They also say they want sine less than 0, which means they also want sine to be negative. So less than 0 means they want sine to be negative. Okay, well, what is sine then? Well, sine, remember, is opposite over adjacent, so that would mean the y over r. Well, we already said that we know that y is always going to be positive, and we said that in order to get a negative, as they said, for the sine, then the only way to do that if the r is already positive is the y has to be negative. So where are y values negative? Well, y values are negative in the bottom part of any graph. So that would be anything that's below the y-axis. Well, y values are negative. That means in quadrant 3 and quadrant 4. That would be this second part. So the problem is they want both of these things to happen. Well, we know that this first one, cosine, is negative. We said cosine was negative in quadrants 1 and 3. Then we said that sine is negative in quadrants 3 and 4. But we want both of these things to happen. Where do both of these things happen? There's only one place where both of these things happen, and that's in quadrant 3. So we'd say that's only in quadrant 3. That both cosine and sine are both negative. Next, we want to talk about some very specific kind of qualities